Okay.
He said okay.
Proj1-2 Lighting, I'm Mike Morris.
Izzy Rogers.
Mike Wild. Big Outlaw. We're the light.
We're the light.
Yeah.
We made Johnny 5. We named it after the sweet 80s movie.
Our objectives were to create a mobile robot and use 3 motors, which included a sound sensor, an ultrasonic sensor, a push sensor, and we used a light sensor too, and we were supposed to follow a black line.
This is the evolution of our design here. And beginning to end, you can see we have a little abstract thought of how we want our vehicle to be. And got a little sensors in the front. That's top view with a little thing on there. It looks like a little beetle, but yeah, with no shades. And as you can see, the illustration of the steering mechanism and different phases of the machine here up until the part where we programmed it. So that's pretty much the evolution of it.
Alright, since we knew we wanted it to be able to steer to follow the black line, we decided the first thing we should figure out is how we were going to make it steer. So we kind of set out using automotive technologies for the older ones and made a rack and pinion, not rack and pinion, drag link type steering. So if you can see the first motor actually, and this is the drag link, so it actually follows. So that's what we did first, and then basically the rest of the chassis was built around the steering. We did have some problems with being able to get the sharpness out of it, or if it would turn too far, it can get stuck and will lock into place. And so we actually had to lengthen the one axle so that it could turn sharp enough, but then we had to shorten it because it actually can get caught on the little notches on the side of the motor. So after we got that figured out, it was pretty smooth sailing.
Like he was saying, we built all the pieces kind of separately and then put everything together, and that wasn't the best way probably. And so we just came up with some sort of box frame design, and there's without the brick and everything on top of it, that allowed us to connect everything together. The sound sensor, we wanted it to activate, but we had problems at the very beginning with the programming. It would always think it was 100% volume. Tried calibrating it like you guys said, and didn't really help, but we finally got it one calibration that worked. And so now adding, I don't know, I pointed out here, everything's kind of controlled by a variable, so the program doesn't run until it hears the loud noise. We were able to fix it. And our program was way too big to actually, can you see that?
Yeah.
It was way too big to be able to fit onto a screenshot or anything, so I built a flow chart of it. Oh, you can see it on the computer screen. Anyway, push button on the back starts the program, so we could actually utilize the push button. It waits 2 seconds, and then it sits there and waits for somebody to say go. And when you go, it starts rotating the eyes so that for the object detection is the ultrasonic. And it also goes over here and uses the ultrasonic to detect if there's something in front of it. If there's nothing in front of it, it reads a light sensor. And if it reads white, then it steers left. If it sees black, then it steers straight. Obviously, it always goes forward at the end of the loop. And then at the very end of the loop, it detects if the push button started, so that way you can stop the program without having to push the back button. And that's it. Go. Oh, go. And it goes really slow. It's like the slowest lightning ever.
Doing
So cute, he wiggles his head.
Catch it.
I think you messed with the steering a little bit.
The problem with the paper sliding out from under the robot too.
Yeah.
Too much torque. Got like a piece of paper or something minus that bigger, he actually stops.
Thank you.
And that was a full revolution. Oh yes. I'm gonna just keep doing it.
Let's watch it infinitely.
Doesn't have to worry about the start. It's not the same name.
And how can you stop it?
Just like that.
Okay. Yep, thank you.